Hi, this is Quantum Mechanics by David G. Griffiths. As in the previous lectures, we have studied that quantum mechanics has a probabilistic approach. Probabilistic means that we cannot find the exact value of any physical quantity, but we will find the probability of that quantity. So now we have in this lecture we have to discuss some concepts of probability. We have discrete variables. First we take a discrete variable like 1 2 3 4, not a continuous variables. Now uh, let's suppose we take an example that we have a room and there are some people of different ages. We have one person of age 14 years, one person of age 15 years, three people of aged 16 years, two people of 22 years, and two people of 24 years, and five people of 25 years. Now nj represents the number of people of age j. N is a function of j. N represents the number of those people who have age j, like n of 14 is equal to 1 mean number of those people who have age 14 is 1, and number of those people who have age 15 is also 1, and number of those people who have age 16 is also as 3, and so on. So these are the number of people of different ages we can represent like this. Now total number of people in the room, total number of people, if we sum all of the number of different ages, so we will get the total number of people in the room. This is histogram of that concept. In the y-axis we take number and on the x-axis we take the age. So it represents that 14, the person who have age 14 is only 1 in number, and also the person who have age 15 also is 1 in number, and the person who have age 16 is or 3 in the room, like 1 2 3. So there are 3 people who have age 16 in the room, and just like the others number. So this is the histogram of different ages. Now we have a question that if you selected one person by random, what is the probability of age 15 if you want to select randomly one person from the room? So we are asking that what is the probability of age 15? How probable is that we will select age person of age 15? So here is the formula. Probability of age is given by probability of number of person who have age 15 is equal to 1 or 14, because sum of all is 14 and we have to select only one person. So we have to select 1 of 14, so probability is 1 of 14, because a person of age 15 is only 1 in the room, and just like the person who have age 16 or 3 in the room, so the probability is 3 over 14, 3 total of 14. So we can also say that generally that probability of any age is equal to number of that age, how many people of that age consists, and divide by total number. So this is the general form of the probability. Now in particular this is the rules or laws of probability, that summation of all probabilities must be equal to 1. So if we add all probabilities we will get 1. Now question number 2, that what is the most probable age? So the most probable age is 15. Main 15, most probable age is 25. It is because that more number of people have the age 25, so we have a maximum probability of age 25, because there are 5 people, so we can get we have the larger probability to get the age 25. Now number third question is what is the median? So median is 23. Median is the central point from which the higher level ages and the lower level ages are equal. So from 23 we have 7 people higher ages, and lower also 7 people. So that's why median is 23. Now, what is the average or mean age? So this is the formula for the average. Average of the age is equal to summation of age and number of that number of people at that age divided by total number. So as we know that number divided by number at some ages or at a particular age divided by total number is probability. So we can write that the average is equal to age multiplied by its probability. So we can find the average of our people, that one person have the age 14, one person in 15, three persons have 16. Number multiplied by its probability, or number multiplied by its number of age multiplied by its number of age. So we have 3 and 16, 2, 22, 2, 24, and 5 people have 25 ages divided by 14. Now this is equal to 294 divided by 14 is equal to 21. So here is a point that it is not necessary that the average or the median must be a number that should be present in our data. It's not necessary. Here 21, here the average is 21, and 21 is not present in our data. Here some people have 16 age of 16 years, some have 14, some have 15, but there no people have the age 21. So it's not necessary that the average must be present in the data. Now the question number 5 is average of the square of ages. If we first find the first find the square of the age and then average it. So here it will be equal to j square, probability of j. We know that the average of ages is equal to j age multiplied by its probability. So we can generalize this for all function. It is not only necessary to be for the age problem, but we can solve this for all generalized function. So we know that j either age square average or function square average and function average square, they both are the different. Let we have example, let two person with age 3 and 1 years. So if we find the age square average, so it comes out that j square probability of j. So 1 and 1 have probability of 1 over 2, and 3 square probability of 1 over 2. So we have get 5, and if we find the average, the j average square, so j average square comes out 4. So means that j average square and j square average both are different values. Both are not the same. So we will discuss this was discrete, and in the next lecture we will discuss continuous variables.